Good morning, everyone. We're about to get started here. My name is Brad Hollister. I'm in the Northeast Region office today, and we're going to be talking about Wisconsin DOT's design model implementation. So this is going to be a non-technical presentation. I'm not going to be jumping into Civil 3D unless we run out of things to talk about. So this is also being recorded, and the material that I'm presenting today is really intended for a broader audience. Civil 3D users, yes, but even some of our project managers, people that maybe don't get an opportunity to work in Civil 3D often, I think they would benefit from this as well, because it's going to be talking more about the policy that we've implemented, why we made some of the decisions that we made. So because it's being recorded, if you think there's others in your office that might benefit from hearing, please promote it. So I'm going to start today by giving you guys a brief status update on our Civil 3D deliveries coming out of the Methods Development Unit at Wisconsin DOT. And then I'm going to give you some basic information about our new design model requirements. I'm going to talk about the process that we went through for implementing those new requirements and explaining, some of the thoughts behind some of the decisions that we made. I'm going to also introduce you guys to an estimating tool or an estimating process that's meant to estimate the effort associated with delivering design models at the project level. And then we'll have an opportunity at the end of today's presentation to ask questions. So for the offices that are watching remotely or people that may not be at a DOT office, please submit your questions through the chat function in Bridget. For the people here in Northeast Region, please hold your questions during the presentation. I have quite a bit of material. I condensed this a little bit, and we'll address your questions at the end of the presentation. Okay, new stuff that we have coming out of coming out for Civil 3D. We have by now, I think most of Civil 3D users using our content are anyway. They're aware of the software problem that we had with our section views and how it might affect cross-section output. The fix for that has been distributed. Our Civil 3D standards released last week on April 8th. That release contained the fix for that software problem that might be affecting section views. I want to emphasize that we didn't get any reports of any projects that were impacted. There may be some out there though. It's just given the nature of the problem and given the way we're using Civil 3D and our workflow, we saw it could potentially be a problem that would cause problems for projects. That's why we took that proactive stance with the communications that we sent out. Now that the fix is out there and there's documentation with that fix, you guys can go ahead and fix any section views that you think might have been affected. And the way it's put together now with the software fix in place, it should retain the work that you put into those section views. Also coming out, it's still being tested. It's still in beta form, but we've been through several iterations. We think it's very close. And we're very hopeful that it's going to be released with our May release of Civil 3D standards. We're calling it our break line extraction utility. So one of the deliverables with design model is the longitudinal break lines for your proposed surfaces. And the idea behind this break line extraction utility is that you point it at your refinement surface. Remember, your refinement surface, that's your finished design work, or it's the current state of your design work, your surface models that are in the refinement surfaces. You point that macro at the refinement surface. It works through the refinement surface definition. It chases all of the things that define that surface all the way back through the Civil 3D project data to source objects. And then it extracts, if it was a corridor, it extracts the feature lines that were used in defining that corridor surface that was put into the refinement surface. Extracts all those break lines, puts it in a separate file that ultimately becomes your break line file. It does the same thing if you were adding feature lines or 3D polys as break lines. It grabs those things At the end of it, you should have a completed brake line file. Now, because of the design process, some of those brake lines might be obsolete and no longer part of the surface definition. So then that macro goes through and it does a verification process. And it flags every brake line object that was extracted that is no longer coincident with your refinement surface. Puts it on a different layer, and then you, the designer, can go through and make decisions as to whether or not there's something wrong with the data because that brake line should have been part of your work. Or, yeah, that was obsolete. I understand why that is, and you can delete it out of the brake line file. So we've had a workflow in place for delivering brake lines, but it was very manual. There was a lot of steps. There was a lot of interaction with the users. So a lot of potential for error, plus just a lot of work. We never released the training associated with that workflow because we've been working on this brake line utility to replace that workflow. And we're just about there now. We're just in final testing, and you can look for that in the May release. Regarding our design standards, we're presently going through an effort to develop new plan sheet examples in the FDM. We've gotten several comments from people over the past couple of years that said that the plan sheet examples are no longer current with what my output looks like out of Civil 3D. And that's right, those plan sheet examples, they're actually back from MicroStation days. It was the MicroStation standards that you're seeing producing those. So we're putting together new examples, plan sheet by plan sheet for each type. In the interim, until those make their way into the FDM, if you see a discrepancy in the FDM language compared to what you're seeing in that example, it's the language, the guidance language that's in the FDM is what you should follow regarding plan sheet content. And we'll get those examples updated soon too. Finally, we have some new Civil 3D training that's being released very soon, possibly even this week. We have a new workflow idea that's really cool. We're using profiles and profile tools to control the daylight slopes in corridors. And we're using the stationing in the profile to identify where it should be in the corridor for stationing. The full workflow is going to be released. The release is imminent. The work is done. Very, very neat idea because a big part of refinement surface processing was to go back through and readdress all of the daylight slopes. You might have slope transitions going from a 2.5 to 1 to a 4 to 1 in one corridor frequency, right? And that's 10 feet or 25 feet or whatever that frequency distance is, much too fast for that transition. This workflow helps you build it into your base design, those slope transitions. So that's a very interesting, very creative way of using what we have in Civil 3D to make roadway design life easier. Also, we have curb ramp modeling examples coming out. So workflow exercises looking at different types of curb ramps and how to model them. I want to remind everybody that in our FDM delivery requirements, curb ramp modeling is not required. It's optional. The idea being that the designers ought to be able to pick out which curb ramps are going to be a challenge to construct because of the elevations and the surrounding terrain, and which curb ramps will be a slam dunk and won't be a problem at all. And then the designer can depict those difficult curb ramps and include them in the design model deliveries. But it takes time to model each curb ramp, so we only wanted to have that attention put where it was needed. So that's why they're optional. Finally, roadway modeling best practices. That one is not video-based. It's just pure written documentation. It's going to be inserted into the help file in Civil 3D. I think we have 27 best practice tips right now in that article, and that's going to be a living document too. As we learn more, we'll share it. And then finally, we have a new, another new workflow out. This one's not in the form of an exercise, but it's for roadway or for roundabout modeling, and it does not address the horizontal layout of roundabouts. We have other training that talks about horizontal geometry for roundabouts, but it talks about developing the vertical geometry profiles for all the curb lines and really building an entire system of setup corridors and corridor surfaces and surface profiles that are dynamically connected to each other and give you live feedback when you're trying to adjust a profile, say on an approach. You can get immediate feedback on how that's going to affect all the other curb lines throughout that intersection. So it's a workflow overview. It's not a step-by-step demonstration for you to lead through, but the finished data set is included with it. And then, of course, the workflow concepts are there. And we think that's going to do a pretty good job of conveying the idea without having to sit through 6 hours of training. So we're curious to see how that all works out. So good. There's my status update. I'm going to move through pretty quickly. This is part of a presentation that I've been giving at region offices, but I had a little bit more time at the region offices, so I spent some time. I took some liberty to go into details. This is condensed a bit, and I wanted to make sure that I captured all the important stuff, so I'm going to be moving pretty quickly. So our new design model delivery requirements, they went into effect last summer, July 1st of 2014. You can see there the FDM sections. That's where you're going to find these new standards, the new delivery requirements. We when we put the standards together, and if you're wondering if a project is going to have to deliver a design model, there's two criteria that you have to consider. You have to consider the timeline of the project, and you have to consider the project scope. So regarding the timeline, if you looked through the FDM content, you would see that there's language in there. It talks about FIPS life cycle dates. It talks about a solicitation date. What that's all about, what the intent of that is for these new requirements to be applied to new design project work starting up after the implementation date of July 1st, 2014. Design projects that were already underway are exempt from these requirements. So it's only new work starting up after that implementation date. That's the timeline component to it. The other thing you have to consider is project scope. And if you look at our requirements, you would see that it says that if a project is required to have planned cross-section sheets, then that project must also deliver design models. Okay? If you looked elsewhere in the FDM, it would tell you when you need cross-section sheets, and paraphrasing there, if you have an earthwork pay item on this project, you need cross-section sheets. So by association, I guess, if you have earthwork on a project, you're required to deliver a design model, and the content requirements are in the FDM. That's something that we're going to be continually reassessing. We may find that there are some project types that have earthwork that don't really benefit from the effort associated with delivering design models, but as things stand today, it's more across the board, anything with earthwork. And so this is an incremental approach to, and you're going to hear me saying that several times today, it's an incremental approach to implementing new processes. And so we're going to be constantly reevaluating, making adjustments, and then of course we're going to be expanding upon this delivery too to get even more utilization of modeling-based processes. So on this slide here, you're going to see this is a list of the main contents of a design model package. The design model packages contain surface models. So that's their primary component. And you know what? Before I go through this, there's a couple key terms that I wanted to point out. And surface models is one of them. So when I talk about surface models today, I'm talking about DTM surfaces. I think most of us are pretty comfortable with that idea. A DTM surface is a software object. Every civil engineering software that I worked with has some type of DTM surface object within it, and its purpose is to represent terrain. So for our work, those surface models can represent both existing and proposed terrain. But that's the term surface model. The next one I want to talk about is design model, and the way we're using that term now at Wisconsin DOT. That refers to the package of information, the digital data files, that we're extracting out of our civil 3D design project. It's primarily, its principal component is surface models, plus it contains supplemental information to help facilitate the use of those surface models. The primary intended user of the design model package is our construction contractors, grading contractors, aggregate, staking contractors, okay? And it's intended to be used during pre-bid project planning as well as during construction operations. So that's the design model. It's the surface models that we're delivering, plus the additional information to facilitate the use of those surface models. The last term that I want to throw out there is construction model. And the construction model, the way I'm using that term, that is the set of surface models that contractors use in construction operations, okay? Now, the surface models that they're using might be identical to the surface models in the design model. We've had several experiences in pilot projects where contractors chose to use the delivered design model directly in their construction operations. But it doesn't have to be identical to the design model. The contractor can make changes, and the contractor can have full control over how they're using that information. I'm going to talk about that concept a little bit more a little bit later too. But the construction model being the set of surfaces that's being used in construction operations. It could be identical to design model, but it's not required to be. So let's talk a little bit about how the new information that we're delivering is being used. I mentioned its primary intended user is our contractors. They're using it in two primary ways. They're using it pre-bid for project planning and for material or for quantity takeoff and other kinds of bid preparation types of activities. And then they're using it in construction. They're using it slam dunk here, automated machine guidance operations, right? They're also using it in staking operations. So let's dive into that a little bit deeper. The project planning types of things that they're using it for, and we've been working with these sharing models with contractors through our pilot program for a few years now, and this is where we got some of the feedback back from contractors that have been using this. And what we were hearing, what we got out of the pilot program, some of the things that we heard they use this information for, we expected. So on the planning side, the idea that we're delivering more design information about the design intent. We're delivering more detail about the design intent. And we're providing it in a format that contractors can easily consume it, bring it into their software tools, and run analysis on it, okay? And that's big. It allows them to do a deeper, more thorough job of planning their operations. So they're virtually moving the dirt. They're trying different crew configurations. Let's run this project with an 8 scraper crew and let's see how it plays out. Let's run it with a 12 scraper crew and let's see what that timeline and that sequencing looks like. And as more DOT projects start to deliver these things, contractors can start to do a more thorough job of planning their entire operation, at least the DOT side of it. They're able to virtually construct these projects with the information that they're giving in, and it's not taking a lot of effort because it's formatted in a way that they can just start using it right away. So we kind of expected to hear some of those things. There was also an unexpected use that was, we thought, pretty creative or at least pretty positive, a positive development. And it was that they can use the existing ground surface model that we give them for early site reconnaissance. So for earthwork bidding, one of the principal components of that cost equation, haul distance, right? Source of materials and where that material is located. That affects haul distance. So they're able to do early site reconnaissance. Our existing ground model, especially the photogrammetric collections, they're a wider swath of existing ground than what the project limits are. And so we're picking up all the property that's adjacent to the project. Contractors can take that and they can look for the best locations for borrow sites that are adjacent to the project or possibly waste sites, okay? And so when they do make that initial site visit, instead of trying to identify these locations, they've already picked out their optimum spots and they can focus right in on those areas. And then when they start talking to the landowners, remember these landowners, they don't really understand DOT projects and how these things work, okay? And they might have half dozen or more contractors contacting them, asking them, telling them that they'd like to talk to them about using their land. entering an agreement where the contractor is going to alter their property. And I can imagine that that's got to be intimidating for some people for sure. Trying to figure out whether or not it's in their best interest to allow that contractor to use their property, okay? So when the contractor shows up and starts talking to this person, now they can show them the existing ground surface model. This is what your land looks like today. Contractors can easily build a finished ground surface model on their property. They need to, so they know how much volume they can pull out of it, or volume of waste they can put onto it. And they can show the property owner, this is what it's going to look like when the project is completed and we walk away. And it's just a nice communication piece to really help that property owner get comfortable with something. And it's a big part of earthwork bidding, and it helps that whole process. It just helps facilitate the entire thing. So, you know, it's a little bit unfortunate because we've had existing ground surface models for decades now, but we never realized that contractors would benefit in that way from having that information pre-bid. We could have done that a long time ago. We're doing it now, and they're getting the benefit of it now, though.
Some folks are having a hard time hearing.
Okay, I'm going to try to stand closer to my microphone and talk a little bit louder. I heard that some people are having a little bit of a difficult time hearing me. So that's kind of what contractors are using the design models for pre-bid. The construction operations that they're using this information for, more straightforward. Automated machine guidance, that's a slam dunk, right? Whether they're using these models directly in their operation or they're using the full data package that we give them to build their own model, either way, we're making that process easier for them. We're facilitating it. We're helping to facilitate automated machine guidance usage on our projects by doing this. Staking operations as well, being able to stake to an alignment and any point on a proposed ground surface can have value. Think about like roundabout projects and some of the staking challenges and laying out curb lines on those things. There's benefits out there for design model, even with conventional staking operations. So why is Wisconsin DOT implementing these new delivery requirements? In a nutshell, it's to save project dollars, okay? EDC is a group of initiatives. I don't know if everybody's heard of that, but EDC stands for Every Day Counts. And it's a group of FHWA-led initiatives. They've been running on a 2-year cycle. Right now we're in EDC 3, so EDC 2 finished up last fall. EDC 2 ran from 2012 to 2014. The idea behind it, the Everyday Counts initiatives, is to streamline the delivery of projects. So what FHWA is doing is they're identifying across the nation leaders in implementing new processes that are making project delivery more efficient. And they're working with those industry leaders to share these best practices and ideas with other DOT agencies that might be interested in adopting similar practices, okay? So it's been a really well-received group of initiatives with FHWA. We've been really enthusiastic about the benefit out of it, and Wisconsin DOT has been both a contributor and we've been on the receiving end of good ideas with this whole thing too. So it's something that we've definitely engaged in. EDC 2 had an initiative associated with it that was called 3D Engineered Models for Highway Construction, okay? And in that initiative, in the documentation, the research that was done as part of that initiative, FHWA found that projects can save between 20 and 30% of their total cost if modeling processes are used to the greatest extent possible or made possible by today's technologies. So let me be clear here first. Our implementation of design model does not achieve that 20 to 30% cost savings on projects. This is our first step in implementing model-based processes. We believe it's a necessary step too. at the foundation of all the model-based things that we see are the surface models. Most of the model-based things that we see. The foundation is the surface models. And so right now, we're building up our skill sets in designing those surface models. It's an incremental approach to adapting processes, and we're going to take it one step at a time. We do think we get pretty good value out of this implementation, though. We may not achieve that 20 to 30% project cost savings. We recognize that this requires a little bit more effort on the design side, but we definitely believe that the overall project cost is going down because of this new practice that we're implementing. Another industry trend that would point towards modeling processes increasing efficiency would be the design build industry, okay? Wisconsin doesn't do design build, but other states do. Other states will do design build projects. And you guys all know this. I mean, the idea behind design build is you put the design group and the construction group on the same team together, and they're going to work together to streamline delivery processes, right? Well, the industry trend, and it's been for a while now, when you give those design build groups, design and construction, that working together, having full control out of the processes that they use to deliver projects, they're maxing out in using modeling-based processes. Now, let's look at that just objectively for a second. You also have to realize that design build projects are typically the most complex types of projects, right? And for many modeling processes, the more complex project types benefit the most. There's some things that you would do on very complex projects that you're going to get a return on that if you had a less complex project, you wouldn't get that same return on what you're investing for effort. So not all of these processes apply to all of Wisconsin DOT projects. We have to be selective in how we're using this technology. But certainly that industry trend in the design build arena to me, it's a key indicator that there is no doubt that these processes lead to greater efficiency. And we're trying to take advantage of that. Some of the other benefits, one benefit that I don't often get a chance to talk about is the idea that we're doing a deeper, more thorough job of thinking through the design concept when we're delivering design models. We're designing more detail in the intersections, intersection pavements. We're doing things on the model, solving problems that we didn't try to tackle before in design. Problems that were usually solved in construction, okay? Now, that has worked for us historically, but it may not be the best way to go about things. If you have a problem, in our world, if you have a problem, the earlier you solve that problem, the earlier you address that issue, the cheaper it's going to be to deal with it, right? You solve an issue in early design, it's going to be cheaper than solving that same issue in final design because of the rework associated with it, right? You solve an issue in final design, it'll be cheaper than solving that same issue in construction. You solve that issue in construction, it's going to be cheaper than solving it in operations. That's just the way things work. Well, by having the designer develop a more detailed design might expose constructability issues that wouldn't have been caught otherwise. Solving those problems in design is much better than encountering and dealing with them in the field, okay? Now that's something that we really have a hard time quantifying. You know, how do you quantify cost avoidance? I suppose historically over time, if you build up a large enough set of data to do comparison analysis and do statistics and all that kind of stuff, you could probably get information that would point to the cost savings, but we don't have that data and we haven't been analyzing that data, and it's just not what we're going to invest our time in right now. We already have buy-in within the department that we think we're doing the right thing, And so we don't have to justify it to that amount of detail right now. If we're asked to, we might tackle that, but we haven't been asked to. Some of the other things that design model brings value to: visualization, communication, right? These surface models with a little bit of work can represent a project concept, especially for people that aren't used to looking at our 2D output. You know, we can put roll plots on the wall and we might have a profile and a plan view and try to show somebody their property or their driveway, and they see that's interesting, but try to explain to them what a 4-to-1 slope is going to look like on their lawn versus if we get that easement from them and we can lay that slope back. They don't always understand those concepts, and we use terms they're not familiar with. But the 3D model, the picture conveys that idea more quickly, more completely, especially for people that aren't familiar with our usual 2D output. And let's not forget that this is our first step in implementing model-based processes, okay? There's things out there today, there's technology out there today that many of our projects would benefit from. You know, grabbing 3D utility information and running clash detection on some of our more complex projects, everybody intuitively sees the value in that. You need to get into the 3D design arena to start taking advantage of some of those things. And that's where we're heading. So our implementation process, it actually took place over a much longer period of time than most people realize. In 2007, 2008, we had just started our process of replacing Casey, and we were just starting to think about Civil 3D and the workflows that we were going to employ in Civil 3D. At that same time, we were, when I say we, I'm talking about methods development, was involved in an effort to develop a construction specification for automated machine guidance for grading operations. And in that effort to develop that specification, a lot of people came to the table to represent their interests in that effort. You know, we had contractors, grading contractors, staking contractors, model building contractors. We had design engineers, both DOT and consultant. We had construction engineers, both DOT and consultant. We had spec writers. I mean, we had a lot of people, and they're talking about automated machine guidance, modeling, modeling-based processes, the benefits that are being realized out there. And it was perfect timing for us because we're implementing a new system and a change. And one of our goals for introducing Civil 3D was to deliver a roadway design workflow that would produce 100% construction-ready surface models. Okay? We came out of that. 2010, we started using Civil 3D here in the department. 2011, we started seeing our first projects delivered. 2011, we had our first pilot projects, sharing models that DOT staff developed and designed. We had 4 projects, I think, that in that first pilot year. The pilot process along the way, we had some successes. We learned some lessons along the way. I don't want to dive into the details in that, but I will say that, you know, the projects that struggled delivering models, it manifested itself in several different ways. We had more than one project that had troubles. But at the root cause of it, when we were able to really figure out what happened here, at the root cause of it, there was a key workflow concept that wasn't carried through on. And that workflow concept is make the development of the model your design priority and make the development of your 2D output secondary to that. Okay? You design the model first, then you cut cross sections on your model. You don't work in the corridor and design cross sections like we used to with some of our old design tools. It sounds like I'm just playing with words there, but it's really a big deal. And every time, every project we had in our pilot program that was not able to successfully deliver models, that was the core reason. Sometimes it might have been delivery pressure. You're running out of time. PS&E date's coming up. You skip some processes. You go straight from corridor to cross section. That was some of the reasons. There were other reasons too. But at the core of it, that was what was happening. The model wasn't being given the highest priority in the design process. But things were going well enough with the pilot program where we were comfortable enough to announce in 2012 our intents in implementing new delivery requirements that were going to require design model delivery. 2013, we started getting serious about developing the content of those requirements, right? And remember, I said design models, the primary intended user is the contractor, right? So the first thing we wanted to do was nail down content, and we went to the primary intended user, the contractors. We got some volunteers through WEMA that worked with us. They spent a lot of time giving us really good feedback, telling us what they find useful, what formats they can most easily use that information in, okay? Helping us determine level of detail that's appropriate. And we learned something from the contractors, even though we had had several pilot experiences and we had gotten that feedback, and we thought we had a pretty good idea of what our content ought to be in design models. We learned that our contractors are not all using automated machine guidance technology in the same way. And that was a key change for us in how we were approaching, because we had been thinking, remember, 100% construction-ready surface models. So the concept that we had in our head was the designer delivers the models, and those models are used by everybody in construction. We came to find out that over the past decade and a half, contractors had been creative in using this technology. And the differences in their operation sometimes worked their way into actually the construction models that they were using, okay? One contractor that worked with us as a volunteer in particular really drove this point home with us. When we had a chance to work with that contractor, we saw that this contractor was building models that were much more detailed than we were asking for in our design deliveries. And they're doing it on every project. They're investing extra effort into the model. And when we talked with the contractor about what they're doing and why they're doing it, it became apparent to us that this contractor was doing this because they believe it gives them a competitive advantage. So we want to promote that kind of innovation on our projects, right? Or at the very least, we want to get out of the way and let it happen. So the whole idea of design delivering a model that'll be used by everybody, that kind of fell apart with that realization. And it became more important for us to understand how they wanted to build their models with data that we could give them. And that's where the longitudinal break lines really really elevated their importance in the priority of our deliveries. Because we realized that these contractors that don't want to use our models directly, we can still give them things that are of value, and they're telling us the longitudinal break lines. They can build the extra detail into their surface models if they only have those break lines. They can't do it when we just give them the surfaces. So the surfaces are still important, but the break line importance was elevated really in the way we were thinking about things. And that's really what led to the development of this macro that I talked about a little bit earlier today, because we want to make it easier to deliver those. And it's just, there is no straightforward path to do that directly in Civil 3D. So we had to do some custom development. 2014, the winter of 2014, we kind of wrapped up the work with the contractors, and we were ready. We finalized our content requirements, and we were ready to start talking to the design community. And we put together, partnering with ACEC, we put together a group that we called the Designer Task Force. The Designer Task Force was made up of 4 consultant designers that were fluent using Civil 3D and understood our workflows the way we were training people to use Civil 3D. We had 4 DOT designers, and then we had 2 people for methods development in that group. In this group, the goals that we had for that group, 4 primary goals. One of them was to confirm that the design model content requirements that we had just finished with contractors, confirm that that was achievable, that we could deliver it. The second one was to identify all the extra work elements that design model delivery introduces into the design process. The third one was to develop a means of estimating the effort associated with each one of those extra work elements. And then the fourth one, somewhat unrelated, you're probably seeing a pattern there. We wanted to talk to the group about interim design model delivery, the benefits and the impacts of asking for those things. So we starting in January 2014, we met several times over the course of a couple months. We were easily able to confirm that this was achievable, that we could deliver these things the way the requirements were asking for them. It took a long time to arrive at that extra work element list. We found that we had to do a better job of defining the detail that we wanted to see in the design models. So we had a lot of conversations around that. Then we started to talk about workflow and everything else. We all had to have a really good understanding of the workflow that we were talking about for a 2D delivery against the workflow that we were talking about as a 3D delivery. Because remember, we're identifying the extra work. So we had to compare the two. A lot of workflow discussions, a lot of really interesting and meaningful conversations for us. And and over the course of probably about 3 months of those meetings, not everybody on the designer task force was able to stick with it for the entire process. Workload got in the way. Fortunately, we were still able to keep symmetry. So at the end of the process, where we delivered estimate information, we had 6 people deliver that information, okay? 2 consultant engineers, 2 Wisconsin DOT design engineers, and 2 people from methods development, okay? The process that we put together for estimating is pretty simple here. We asked around and we found out that there was a lot of different ways to estimate our 2D deliverables, the effort associated with design. People were doing it differently in different organizations. Within Wisconsin DOT, project managers were doing it differently. We didn't want to get into that. So we said, develop your design estimate for 2D deliverables the way you always had, using whatever information you've been using, whatever processes you've been using. Then take what the designer task force put together, this estimate tool, and develop what we'll call the design model estimate. That's the extra work associated with design model delivery. Add the two together, you get your total design effort estimate, right? So when we were pulling together those extra work elements, we really got into the details, very granular level of identifying extra work elements. Just to kind of demonstrate that point, one of the extra work elements that we identified is you have to write out a land XML file for your alignments and profiles. We all estimated it at 15 minutes, which was the smallest unit that we were using, a quarter of an hour, but it's still something we had to do. It's something we didn't do before. So we got into the details and we did everything we could to identify all of those extra work elements, okay? And when we pulled that together, we took a break as a group. And we came back 2 or 3 weeks later and we had a day-long meeting and we shared our individual estimates for those extra work elements as a group. So each task force member in that break period had some homework to estimate each one of those extra work elements. And then we came back together as a group and we presented our estimates to each other around the table, work element by work element. And we talked to each other. We didn't all arrive at the same estimate values, as you can imagine. And we talked about that. We talked about the workflow that I was thinking about using. We talked about the workflow that you were thinking about using. And we learned. And all of us, the entire group, at different times during that conversation, was changing our estimate values because we were seeing different perspectives. We each only brought the experiences that we had to the table for that group. And so we were learning from each other. All that being said, we still did not arrive at a consensus on each extra work element, the amount of effort it would take. And that's okay. I don't think it would have been possible to keep everybody happy and still say we arrived at consensus. That was okay. So the information that we put together as a result of all this, it's available. And you'll see here's where you can get it from. It's on our website, and there's the address where you can get it from. And with it, you see a summary report that summarizes our implementation activity and how we developed this information. But you're also going to find a spreadsheet. And in that spreadsheet, it's a list of all the extra work elements that we identified. And then all 6 individuals who delivered estimates, each one of their estimates for each extra work element. And you'll see that there was some variation there. We did not arrive at consensus, and that was okay. So when people see that for the first time, they see that spreadsheet that we put together, they think, okay, that kind of makes sense. Different projects, different amounts of complexity. I think I'll use the higher estimate values for my more complex project work and the lower values for my less complex project work, right? No, that's not true to the way we developed that information, and it's not the way we intended for people to use it. The values, the range of values that you see together in those 6 estimates, they don't represent project complexity, a range of project complexity. What that represents is 6 different people's personal opinions. And yes, some of these extra work elements are sensitive to project complexity. That is correct. That side of it is correct. However, when one of those extra elements was sensitive to project complexity, we dealt with it in the extra work element list. Let me show you that. So here's just, I know you can't read it, but that's what the spreadsheet looks like. And you see there I have 2 areas. On the far left, that's our list of extra work elements, all right? And I highlighted in red and then in green. So let's zoom into that red area first. That red area is actually just task number 1. I think we had finished with 19 tasks. That was task number 1. The idea behind task number 1 is to deliver design models. The corridors require more detail to be in them, okay? And that detail doesn't come from the software, it comes from the designer. And it takes time to think through that stuff, to deliver that extra design detail, okay? But different project types, different complexities leads to different estimates. So rather than showing a range of estimate values for project complexity, we put a range of work elements identifying different project types to give people a sense of how project complexity would affect those estimates. Let's look at the next example. This one is about intersections. With design model, we're developing a design that completely shows the pavement through an intersection. All of the warping of the pavement to bring those 2 roadways together with good ride and good drainage. We didn't always show that in our 2D deliverables, especially on rural projects, right? We're doing it now, and that's coming from the designer. It takes time, right? But different intersections have different amounts of complexity, and that was meaningful for the estimates too. So we broke out that task number 2 into several subtasks of different intersection types, right? And then we delivered estimates on each one of those intersection types. So we dealt with project complexity in a different way, and we didn't intend for the range of estimates to be used to represent project complexity. Again, those just represent differences of opinion. That's what they represent. So the department, this was a technical report. We didn't develop any policy here. We just gathered information, all right? And then we brought it to the policymakers within the department, and Bureau of Project Development made a decision on how to use this information. And the instructions that are being given to Wisconsin DOT project managers are to negotiate design contracts to the low end of these estimate values. That's the department's policy. Holy cow, I'm on time. I didn't expect that. I feel like I'm forgetting some stuff. Well, it's 11:30. Let me just kind of wrap this up a little bit. So with our new design model implementation, we've recognized that to deliver design models, it requires effort, okay? Let me talk about that extra work element list just a little bit more for a second, okay? As we were working with that stuff, and we came to realize that all of these extra work elements, they come into one, they fall into one of two categories, okay? And this is information that we ended up including on the spreadsheet because we think it's valuable. So when people first see the hours on these estimates and they see that extra work element list, the natural assumption is, okay, all this work is to deliver design models. And that's not necessarily the case, okay? Some of this work is building or delivering better designs, developing more design detail. So we realized that all these extra work elements, they really fell into one of two categories. One of them I'll call value added. This work that was identified adds engineering value to the design delivery. It adds engineering information, helping better explain the design intent, okay? Other extra work elements don't add any value at all. The one that I talked about where we have an extra work element to write out a land XML file, that doesn't add any value or engineering value to the design delivery. It's just something you got to do, you know? So they fell into those two categories. Either they're adding value into the overall delivery or they're not, right? And we put a column in the spreadsheet. It's over to the side of where all those estimate values are. And I can't remember the name of that column exactly, but it's basically adds engineering value to the final delivery. And we flagged all the extra work elements that we think add value into the design delivery versus those that don't. And we think that's important too, because that perception that this extra work is only there to give models to contractors. That's not true. There's value to the additional information that we're designing. Solving those constructability issues earlier in the project delivery process is more efficient. So yeah, we recognize that we are adding additional design effort with this new policy, but we believe that the overall project cost, design and construction, is going to be a net gain, okay? We're convinced of that, or we wouldn't be going forward with this. I'm kind of mentally going through it because I have some time here, and I'm going to open up to questions in about 5 minutes, but there's one more thing that I actually meant to include earlier in the presentation, and I didn't, so I'm going to correct that right now. There's one more thing I want to tell you about our design model, the new policy, and it's that the design model information that we're delivering is not contractual on construction contracts. It is contractual, it's a contractual requirement on design contracts, but it is not part of the construction contract. It doesn't belong somewhere in that hierarchy with the plan and the specifications and all that, okay? And when contractors first hear that side of it, I've heard more than one contractor come out with a perspective that I'm about to share. And I think it's important that I share this with you guys because I think you guys are going to hear it too, okay? I also, before I go out and blurt it out, I'll say that I think it's a minority position. With all the contacts and outreach that we've done, it's certainly been a minority perspective, but it's a valid perspective, okay? And what I've heard a couple contractors say is something along the lines of, okay, we understand what you're doing, Mr. DOT, and this is great. We think you're doing a good thing. But here's the thing. If you're not going to stand behind the design data that you give me, I'm not going to use it. And that's a valid perspective to have. Every contractor, when you boil down everything, when they're putting together bids, what they're really doing is they're assessing risk. And they're finding their own solution for how to mitigate that risk. And using this design model data that we deliver, there is a possibility that it won't match plan information, right? We do as much as we can as designers, and we did as much as we could in putting the workflow together to help ensure that the two are synchronized. The whole cross-section structure, the data structure behind our cross-sections, We don't take cross sections right from corridors. We take them from our surface models. That's a quality control measure, helping ensure that things are synchronized, right? Plan sheets matching models. Still, it's a valid perspective for a contractor to have. And there's going to be other contractors that are going to say the same thing. Well, let's go back to where I was a little bit earlier now, because let's think about this for a second. When I say it's not a contractual document for construction contracts, just to make sure everybody's on the same page with me, what that means is if there's a difference in the design model from what's shown in the plan, and if the contractor loses work or has to redo work because of that incorrect design model information, that's the contractor's problem. The contractor contractually must deliver the project according to the contract documents, which is the plan. So some contractors, the majority of contractors that we talk to, they're going to invest in some quality control, checking the design model information. They believe that it's going to be less work to do that than it is to reverse engineer models completely from plan sets like they have been before these deliveries started. They think it's a net gain. Other contractors, they're going to have that same perspective, and you guys are going to hear it too. And I've been part of a conversation where we had some design people in that same room having this conversation. And I've seen, oh, throw the hands up in the air. Oh my God, why are we putting in all this extra work, giving you models? You're not even going to use it? That's okay. That's okay. Remember, the extra work isn't just to deliver models, number one. It's to deliver better designs, all right? Number two, let's remember that this is an incremental implementation approach. This is our very first step in implementing model-based processes. The department has already decided that we are going to study making design model information contractual and construction contracts. We know it's a huge step. We know we're not ready for it today, but we're going to study it. We didn't decide to do it. We're going to figure out what's impacted, who needs to be part of that conversation, bring everybody together, and let's see if we can get this done, okay? So we're going to be taking that on, that study on. If we're ever going to get to that better or deeper implementation, and I do believe it would be a more thorough, complete 3D design concept, if the contractor could build right off that data, that is a better implementation in my opinion. We're not going to get there, though, without having a proven track record of delivering design models successfully and correctly. And that's what we're doing now. We're building up that experience. We're building up our proficiency in 3D design, so when we're ready to make that decision, at least one consideration is out of the way, that we're going to be good, that we'll be able to be confident that we can deliver these things because they're going to be contractual now. So it's an incremental approach. Once again, you're probably sick of hearing that. But I just wanted to share that because I know how frustrating that can be. I've seen it on people's faces when they hear it. We're going to see it again. We're going to hear it again. Again, I don't think it's a majority of contractors that have that perspective. I definitely think it's the minority. In our pilot projects, that would bear out that most contractors, and many contractors are even using our design models directly on our pilot projects. Other contractors have been choosing to make changes to the design models. Hey, it's their model that they have to use in construction anyway. They're taking on all the risk. They can do with it what they want, okay? But even the ones that are making changes to those models, when they choose to use our information, they're finding value in the information that we're giving them. And again, we're building up our proficiency so that we can get to those next levels of implementation. There, that's a little more like it. Now I'm 10 minutes late.
We got the first question in, Brad. With design models being a deliverable, will the amount of information and or sheets required in the plans be reduced?
Not today. And I didn't catch the full wording, or I don't remember the full wording of the question, but today we did not reduce any of the information that we put in the plan. And before we got there, I think we'd have to make that model information contractual, right? Certainly, on the technically speaking, a model could replace some plan sheets, okay? But first of all, it's got to be contractual. And second of all, we're just not ready for that step yet. So right now, we have all the same information in our plans that we've historically put into them. We're just adding more information that we're delivering.
Next question, do we have a rough time frame of having 2016 standards available?
Okay. Do we have a rough time frame of having 2016 standards available? Historically, we've been through 2 version upgrades now with Civil 3D, and both of them we were able to release standards in February. And when I talk about February, I'm talking about February 2016. I feel like we're in a better place this third time around. Last time around, we had a complete overhaul of our internal distribution system standard structure, and it required a lot of testing before we could go out. Now we have a system in place, so that whole side of it is taken care of. So I think we're in a better place to deliver 2016 a little bit earlier than our previous 2. My conservative answer is February 2016. I'm hopeful we'll get it out 4th quarter this calendar year though, and I'll provide updates at the next ACEC user group meetings as we start to get into that work, so you guys have a better sense of what that timeline is going to look like. 2 questions so far. So they told me to prepare for dead time in case, so let's see. What we could do, yes, Enrique.
So we are talking about bringing designer and bringing the contractor together, in my understanding, because we are designing for the construction, and there are like 2 different ideas. Is there a way of coming up with the projects when we start them up to have particular contractor coming in that will be working on it, where I'm probably talking future, where they will use specific machinery, specific equipment to build, which would be fit, the Ultra B, not the end, but the Ultra B purpose. So would that be the future of our happiness?
Yeah.
Happy marriage?
Yeah, that'll be all rainbows and lollipops, as a good friend of mine likes to say. So Henrico's question was, in her, the way she's digesting this, she sees construction and design coming closer together. And is that going to be integrated even further as we go forward? I mean, I agree with you. I see that side of it. I think of this a little bit differently. I think of it as, we still have 2 separated processes, design and construction, but we're changing the way we represent design intent. We're not changing the design information, but we're changing the way we communicate it to construction. And we're trying to gain efficiencies with that. And I think that this goes further as time goes by. The surface model concept, it was the low-hanging fruit, right? We knew we had to achieve it. You don't go any further into 3D design if you can't do surface models. So we knew it had to be done, but we knew also that it was going to be a net gain. So we could sell this implementation, right? Because it was going to be a cost savings measure. But there's other things that we could be doing, and we're looking towards those. So on the model side, we may add more content to the model that we want to share. There could be a day where we're collecting utility information, existing underground utility information, and including that with our model deliveries. We're developing processes of doing clash detection if we're collecting that 3D utility information. So it's helping the design process as well as the construction process. Our proposed facilities, pipe networks jump right out at me. We're not currently including pipe networks in our design model deliveries, but we could. So there's a lot of things I think going down, as we go down, as we follow down this path into the future, that I think can be added to model content. I think there's a lot of processes that are out there today that some of our projects would benefit from. So I definitely see us moving deeper into this as time goes by. But again, it's probably going to be the same type of incremental approach. We're going to keep grabbing the lowest hanging fruit, and we're going to do that one. And we'll keep working our way through this as we go. Well, thank you for the question. Does that kind of, good, thank you.
When you mentioned that contractors are modifying the surface models for their construction operations, are they changing the design, or what are they doing exactly?
No. Hopefully they're not changing the design, or they're going to have trouble matching what it says to do in the plan, right? But the contractor example that I talked about that we worked with during our content requirements development part of our implementation, what they were doing is they were adding more detail into their models. They're producing models at 1 foot frequencies, okay? And when we give them surfaces, they can't add that detail to the surface. But when we give them longitudinal break lines, they have tools that'll take into consideration vertical curvature of profiles, horizontal curvature of alignments, horizontal curvature of target objects, and it will chord out those individual line segments. We might deliver a model that has a 25-foot spacing, frequency spacing. They call it densify. They can densify the models with the tools that they have, and it gives them a better model, which they believe gives them a better construction operation, okay? Another example, something that they're doing different, some contractors want to do differently, is undercutting our slope areas for topsoil, okay? So we show our design models the exact same way we show our cross sections with proposed ground at the top surface, okay? But you could show a subgrade, allowing for the thickness of topsoil that you're going to put out there. And some contractors are doing that. So they're actually modifying the surfaces. In that case, reconfiguring or reconstructuring those surface models to suit their operations. You got to remember, these guys have been doing this for over a decade, 15 plus years, even on our projects, okay? And they have staff that they've invested a lot of time and effort in training them. And the staff have a long history of working in that environment that they've created, the automated machine guidance environment that each contractor has created. These guys are heavily invested in this stuff, and they don't want to have to change it if they don't have to. And they may have found efficiencies with some of the things that they're doing, and they don't want to give that up. So they're not changing the design, but they're making that design model information match their operation, is what they're doing. And when we talk about contractual elements of a design model, to me, the surface model is going to do the best job of representing design intent. Because I've had people ask me in conversations like this, well, if contractors want to use longitudinal break lines to build their road surfaces, and it's the longitudinal break lines that they always use, for those contractors, they may look at our surface model as a guide, but they're building their own models off the break lines, right? Why we even give them surfaces? Well, I think that the surfaces represent design intent better than a set of 3D line strings that we're calling longitudinal break lines. And when it becomes a contractual document, I think the whole concept is in a better place, because the surface is a very black and white, clean-cut representation of design intent. Longitudinal break lines depends on how you triangulate them, right? So I think we're in a better place with surface model delivery for advancing this and making our design model contractual in construction. But I also think, you know, that surface model is necessary to represent design intent too. And I don't think that the break line files do that very well. Yet the break line files, as we found out, they are valuable and they're an important part of the delivery. So we have 10 minutes, and Keith, I don't know, you want to try a demo?
I can demo.
So we have Keith Zawinski here as my my tag team partner. I'm going to jump out of the ring. Keith's going to jump in. I mentioned the brake line extraction tool, and we just got a new version delivered yesterday that has not been tested. So
let's test it now.
Call it brave, call it foolish, call it whatever you want. We'll test this thing on the fly. But the big thing here is I just wanted to show you the concept of it. We got a little time to kill anyway, so let's do it. So Keith, I don't know, I'm going to give you control of the remote desktop. Take it away.
Okay, thanks, Brad. Well, let's see how we do with this new product. This data set will look familiar to you soon if you view our upcoming training on curb ramps. This is the data set I used in that training. So this is a refinement surface. This is a top surface, so it's got quite a bit of level of detail in there. We've got curb ramps, we've got gratings, we've got added brake lines. Here's a 3D polyline that was added as a brake line. All kinds of stuff. So the tool is going to have to mine all that information that built this surface and provide my brake line file. So I'm going to fire up a brake line utility. Design surface data extractor called in the macro menu. And there it is. So this is the interface that you'll see once we release it. I don't see the interface changing much from here. We have some options. It's divided into two sections. A section that actually extracts all the brake lines, and then a section that validates the brake lines. Now, we have built in here for the tool will automatically move from the extraction phase to the validation phase automatically, so you don't have to do it in 2 steps. And in most cases, this is probably what you want to do. But if for some reason you wanted to see the raw output, you could turn that off and just see what you get before validation. So what the tool is going to do is it's going to extract any brake lines that were added. These could be like 3D polylines or feature lines that were added to the surface. It'll extract all the corridor feature lines that were part of the surface definition. It will, in fact, extract even corridor links if you've included those in the surface. Now, I'll remind you, we don't want corridor links defining our surfaces. So they're in there really as a flag for you. If you see a bunch of corridor links that show up in your brake line file, you know you have a problem you need to look at. It's going to extract grading surfaces. Now, gratings are a unique object in Civil 3D, and we can't really extract the actual brake lines of a grating. But what we can do is we can extract the 3D or the triangle edges that made up that surface. So we're going to deem that as our brake line definition for grading objects. And then it'll also extract any line objects that you were added to the surface. So we're talking AutoCAD lines. So I'm going to pick the surface I want to extract from. I'm going to extract from my refinement top surface. You can choose what template you want to dump those brake lines into. By default, it's just going to point to the ACAD DWT file, which is fine. And then it'll ask you what file, what you want to name the file, the location. So we'll give it a name here. And then you need to specify the data shortcut project folder for your surface, for your project. This is how the tool can find all the information in your project. By looking at that data shortcut folder, it'll know where to look for all the entities that made that surface. So now I'm just going to hit this button here to extract the information. And here you can see it's analyzing all the surface operations that built that surface, all the pastes. It's looking at the order of pastes, and now it's going to go open all the drawings that contributed. So here it's opening a corridor file. It's pulling information from there. Now it's pulling from another corridor file that made the curb ramps. Now it's pulling all the line objects that were added in the refinement surface drawing. It's trimming and deleting anything that was made obsolete by an object paste. So if you think about the order of operations for building a 3D or a refinement surface, first you paste in your datum, your refinement datum surface, which is made from the corridor datum surface. Then you paste in the corridor top surface. So everything that came from the corridor top surface is going to nullify any break line that came from the refinement datum surface that was inside that footprint. It's going to trim and delete any of those lines automatically for you. So it created the file, and here is what you end up with. These are all the break lines. It turns them into 3D polyline strings. And a neat feature with the tool is I can flip on this little button right here, and the process that this tool uses, it's actually assigning X data to all the elements. So I can actually just hover over this, and it's going to tell me everything about that break line. It's going to tell me where it came from. It's going to tell me the feature code of that feature line from the corridor. So you can have a better understanding when you're looking at things that may be flagged as not matching the surface. Here's an example. This break line was found to not match the refinement surface, so it flagged it as red, and I would need to evaluate, is that line segment valid or not? In most cases it's not going to be, but it's something you're going to want to look at. So the real proof here is, if I make a surface out of these break lines, is it going to look like my refinement surface? So that's the real test. So let's give that a try. I'm going to go ahead and turn off anything that said didn't match the surface. And I'm going to turn off all my boundaries. And let's make a surface. Now this surface is from the is being built in the ACAD template, so there's no WIS.dot standards in here, but that's okay. We can make it work anyway. I'm just going to make sure that the build uses our settings. So I'm going to allow crossing break lines. So in the definition, I'm going to add all these break lines in as a surface into the surface definition. So now I'm going to add my boundary to the surface definition. So my refinement all border, that came with the extraction. So we'll see how the surface looks. We'll give this a triangle style. Now it should look, we shouldn't have any spikes or anything. It should look pretty good. I'm going to turn off that grading object so it looks a little cleaner. And you can see the curb ramp looks good. We got curb ramps here with pedestrian curbs. That looks good. So generally, I'd say the testing is looking pretty good so far, Brad.
Hopefully we get that thing out in May. It's still got to go through our quality control process, but we've been through several iterations already, and it is getting very close. So, Jared.
Once you, with this file that you're working in and what you just did, I'm assuming that this is now static and it's no longer dynamic.
Correct. It is disconnected, yep.
Yeah, I like to think of pulling that model out of the design data as a publishing process. Just like we publish PDF plan sheets out of our design project data, we publish this set of files out of the design data too, and it's all disconnected, just like a PDF plan sheet.
So just as a comparison, I'm going to do a quick volume surface between my refinement surface and this new surface, and we really shouldn't see any major differences in volume. And that looks really good. We've got a cut volume of 0.1 cubic yards and a fill volume change of 0.14. That's pretty much right on. There's probably a triangle leg somewhere that might be flopped or something, but could be a boundary issue, but that's close enough.
Okay, well, that pretty much wraps it for today. Thank you, everybody. Can you be control that?
Sure. Just request it.
Okay, well, thank you, everybody. That's what we have for you today. I really appreciate everybody taking time out of the middle of their day to come and sit and chat with us for a little bit. Today's presentation was recorded. The address that you can catch this stuff at is here on the slide. And if you guys have any follow-up questions or anything like that, you can send them to myself, Brad Hollister, at dot.wi.gov. And if there's anything interesting that I want to share with the group, I'll do that at the next user group meeting as part of my status update. So thanks, everyone, and we'll see you next time around.